First, I would like you to write an equation, which is x squared, y is equal to x squared minus 6x plus 8. Okay. So I'm going to use this as a broad overview of this topic right here. Okay. And I want to also say this out loud too. Hope you get the message clearly. And that is the following section is not just about reviewing for the test. This would also be applicable to your SAT math. Knowing that on the SAT, 30 to 40% of the materials will relate to quadratic equations. So you do not want to overlook anything on this topic. And we are about to say goodbye to quadratics. So, but it will still come back here and there. But the main topic, it's over. Okay. So the first thing I want to ask is this: what's the name of this form? This is called the standard form, right? So this is called the standard form. Okay, and on this with this standard form, what kind of information you can extract right away and use it? You can tell the y-intercept, and that is equal to everybody 8, right? 0,8, right? That's the y-intercept. What else can you extract from here? Yeah, you can tell that it is a positive a. That means the parabola will be opening up, right? So these are the two pieces of information you can get right away, okay? Now, so it's standard form, and then I'm going to ask you a question. And you have to answer this question very honestly to yourself, okay? I don't need the answer, but you have to answer this question honestly to yourself. Since I wrote this and showed you this equation, did you think of factoring? All right. Now, if you say yes, great. If you say no, I didn't because you didn't tell me to, then I would say, well, you need to adopt this habit. Whenever you see a quadratic equation or any kind of quadratic expression, the first thing you should contemplate is going to be, hey, can I factor this? Okay, can I factor this? And if you factor it, then it becomes y equals to x minus 4, x minus 2. And this would be our root form. That means you will know your roots. The roots are 2 and 4. Okay, you know your root form, you know your roots. Okay, that's very easy to extract. So that's a huge thing. If you see a standard form and if you don't start playing with the standard form to think about if it could be factored, this is a work habit that you need to adopt, okay? So that's the root form. Now, why? Why should we get to the root form? Why should we think about it? It's because we want to get more information. Look at the standard form. Just take a look at it. It's not really that rich in terms of the information given to you on the surface. But if you have the root form, hey, now you have a few more pieces of information. That's great. And then we say, wait, hold on. Can we go ahead and change this to a vertex form? I mean, of course we could. But to change it to a vertex form, what do we need to do? We will need to complete the square, right? We need to complete the square. And by completing the square, then you know that you have to plus 9 and minus 9 right here. And the, how'd you get 9? That's a good question. How do you get 9? Well, the way you get 9 is by looking at the number right here. You divide it by 2 and you square it. But why do you do this? Why do you do this particularly? Well, because when you do this, x squared minus 6x plus 9 is equivalent to this item right here. So if you see how they're equal, then that's how we replace them. That's the justification of adding 9. That's the justification of dividing the 6 by 2 and then square it, because that's how we get the parentheses x minus 3 squared. In one of the earlier videos that I made, I said that if you're having struggle in completing the square, chances are you are lacking some practice. And I said in the video, I said that you should really do more practices like this. Can you do the FOIL of these things and all of these things? Okay, both positive and negative. And you just keep going all the way until maybe like 10. And when you do enough, you will see that when we do vertex form, we want to get this perfect square, because now we can tell the vertex. Where's the vertex here? 3, -1. That's the whole reason why we're doing completing the square. Yes. What's that? You still don't understand the 9, right? Do you know x minus 3 parentheses square? That's the first question I'm going to pose. Do you know that this is x minus 3 times x minus 3? Do you know that this is going to be this when you do FOIL? And when you combine like terms, that's what you get. So if you compare, or just take a look at the original equation, we've got this part right here. And what are we lacking? The 9. So if we have the 9 here, then it is equivalent to parentheses x minus 3 squared. Okay, so I understand how this is like creating things out of thin air, and I would confess that completing square was not something that I learned in the first time, and I can master it. No, it took me a few times to really understand it. But what was really the key is that, do you understand what equal means? Do you understand that we are trying to create a perfect square so that we have a vertex form? You have to understand the intention behind the addition of 9 right here, which is to allow us to replace x squared minus 6x plus 9 with parentheses x minus 3 squared. So you should be ready to change your standard form into root form or the vertex form whenever you are presented with a standard form. Okay, you never know what form you'll be given, but if you have a standard form, then you should be ready for it. Now, we have a couple more things to talk about with standard form. Now, earlier we talked about the standard form. We said that you can only get the opening and the y-intercept on the surface. But if you go a little bit deeper by crunching some numbers, you can actually find more information using the standard form. So the question now to you is, do you know how we can extract more information from the standard form? You have the axis of symmetry, which is negative b over 2a. Okay. So I want you to know that these are equipments that should be in your back pocket. But do you know that they are in your back pocket? That is the key. All right. Next one. What else can you tell using the standard form? The other thing that we can find out that starts with a D. Discriminant, which is b squared minus 4ac. Not with the root, all right? Just b squared minus 4ac. Okay, what does it tell you? The discriminant tells you how many roots there are. There could be 2 roots, 1 root, or 0 real roots, but with 2 imaginary, depending on whether b squared minus 4ac is bigger than 0, equal to 0, or less than 0. If you combine these 2 together, what do you get? You can find the roots by using the quadratic formula, which you should know by heart. Okay, you should really know it by heart. You should not miss it. Okay, every single high school student, I believe, should know it. It's a shame if you don't. Okay, and if you know the quadratic formula, I hope you can tell that there are other components that are embedded inside the quadratic formula. Okay, so if you know the quadratic formula, you know discriminants, you know negative b over 2a. Okay, so use your memory wisely. It's what I'm trying to say to you here. Use your memory wisely. So, yes.
Are we going to need to know like quadratic formula?
Oh yeah. Oh yeah. So this is the big picture right here, right? The whole quadratic topic. Like this is how I would prepare students for SAT. I would say to my students, I would say, hey, do you know your quadratic equations? Do you know your forms? Do you know how you can go from one to the other? If you are not showing this level of flexibility, then you are not ready. Okay. And for tomorrow's test, you also need to show this same level of flexibility so that you will do well. Okay.